In this question, we're asked to figure out what the work is to launch something from the planet to an orbit 800 kilometers above the surface. So first we're going to start with a drawing of the planet, and our object starts here, and this is position 1. We'll call this energy level 1 because the object has some energy there. And then it's going to travel away from the planet 800 kilometers above, and it's going to make it to this energy level, energy 2. Now what's different about energy level 2 is that it's traveling around the planet now. So it's a circle. So here at energy level 1, it was at rest with respect to the planet. Now here it's in orbit around the planet. So let's look at the relationship that we need to use. We're trying to find the work. So the definition of work is a change in energy. So energy 2 is our final energy level, and energy 1 is our initial energy level. Energy 2 has both the kinetic and gravitational potential energy. So it consists of both of those types of energy. And if we recall the shortcut for determining the total energy at this point, if something has kinetic and potential energy and is in orbit around something, we can use the shortcut Eg divided by 2. Now at energy level 1, there is no kinetic energy, it's just potential energy. So therefore, and we'll put a subscript here too, and therefore the energy level or the total energy at energy level 1 is just Eg1. So let's expand this relationship. So we know that Eg is equal to negative big G, which is the gravitational constant, times the mass times mass 1, which in this case will be the Earth, times mass 2, which in this case is the object, so that's mass 2, over R2. Now where's R2 on this picture? Well, R2 is not 800 kilometers. R2 is actually measured from the center of the object, which we're assuming is a point, to the center of the Earth. So let's use a different color here. So this purple line is R2. So R2 is actually the sum of the radius of the Earth plus 800 kilometers. Now the radius of the Earth in meters is 6.38 times 10 to the 6 meters, and then we have to convert that into meters, so it becomes 800,000 meters. So that adds up to be 7,180,000 meters. Now we have a subtraction symbol right there, and we're subtracting Eg again. So that's negative G m1, m2 over R1 this time. Now R1 is just the radius of the Earth because when the object is on the planet's surface, that's how far it is away from where the mass of the Earth is concentrated mathematically. So if we factor out, because there's a G m1, m2 in both terms, so if we factor that out and the negative as well, it reduces to 1 over R2. Sorry, I forgot the 2. There's a 2 right there. 1 over 2R2 minus 1 over R1 And if you substitute R2 into here and R1 as the radius of the Earth, which is 6.38 times 10 to the 6 meters, then your answer comes out to be 3.5 times 10 to the 9 joules. So therefore, the work done to launch this object into orbit is 3.5 times 10 to the 9 joules.